Let's talk about pressure volume loop. So this is a graph. Any graph, we look at the x-axis and y-axis. So x-axis is the left ventricular volume and y-axis is the left ventricular pressure. So we look at point D to point A. So there's a drop in pressure, but there is no change in volume, so we call it isovolumetric relaxation because the pressure drops and there is no change in volume. So isovolumetric relaxation. D is the beginning of diastole. So you have the heart muscle, it has relaxation, so pressure drops, but there is no change in volume. So it's right before opening of the mitral valve and complete relaxation of the left ventricle. So from D to A is isovolumetric relaxation. Then at A we can see 60 milliliters is in the left ventricle. This is your end systolic volume. You go from A to B, so you increase volume. There's a little bit of increase in pressure because you have more volume. So from A to B, a little bit of increase in pressure, and you get to a point B, you have 130 milliliters in your left ventricle, and this is your end diastolic volume. Because at B, you actually close all the valves. So the aortic valve and the pulmonic valve, they were closed anyway, and now the mitral valve closes. Mitral valve closes and you have contraction but no change in volume. So from B to C is isovolumetric contraction. Pressure increases, you go up with pressure, but there's no change in volume. Now you get to see that's the moment that you start your ejection phase. And that's the moment that the aortic valve opens. So from C to D, your volume from 130 goes back to 60. And when it goes back to 60, that means stroke volume went out, went into the aorta. So C is the opening of the aortic valve. And D is the moment that ejection phase is finished and aortic valve closes. So at A, mitral valve opens. At B, mitral valve closes. At C, aortic valve opens. At D, aortic valve closes.